Yeah, my name is Vitalii. I work as the engineering lead for two teams, data science and machine learning, in a company called Careem, based in Dubai. Today my talk is in English, but feel free to ask questions in Ukrainian or English or Russian as well. Oops, sorry. I forgot that, yeah. So today I've seen that in the agenda there were a lot of talks about deep learning and image recognition, 3D modeling, convolutional neural nets. I'm not going to talk about any of that today. No formulas as well. I'm going to share some practical knowledge that we at Careem gained while deploying classical machine learning models into production at scale. So first I'm going to explain what is Careem. So Careem is the Middle East's ride-hailing app that is engaged in delivery, transportation, payments as well. Right now we're pursuing our super app vision where we want to onboard third parties as well onto our app that will offer their services, but originally started in 2012 in Dubai as the ride-hailing company. So we operate in 14 countries, 125 cities. We have more than 33 million users in our user base, more than 1 million captains, which is our word for driver in Careem. And we have more than 2,000 full-time employees based in several offices, Dubai. We have several offices in Pakistan, and as well we have our engineering office in Berlin. So yeah, that's about Careem. So today I'm going to talk about scaling machine learning, and first I'm going to explain what is hard about scaling machine learning. And I wanted to ask how many of you here are data scientists or machine learning engineers that do data science as their day-to-day job? Can you raise your hand, please? Okay. How many of you are engineers, like software engineers? Great. Okay, so what is hard about deploying data science models in production? So typically, I don't know if you face this, but I face this as well because I'm a data scientist. I was a data scientist before I became a manager. Sometimes you develop something in your Jupyter notebook. And for those who don't know what is a Jupyter notebook, is like an IDE for like Python environments that helps you easily develop your machine learning models. So you develop your code there, it works well. Then you need to somehow put it into production, and then you realize that it doesn't work. It just results are off, or it just doesn't run because you have a different environment compared to the one that you had on your personal laptop. And apparently, like, it seems that it's not that simple to actually put it into the production at scale, because it's not just like developing a Jupyter notebooks, it's actually a complex project. So first you need to prepare the data, and sometimes when you develop some machine learning models in your laptop, you just get some CSV file that you work with, and then in production accessing the data is slightly different. It appears that you need to query some production database or some data lake like Hive. Then once you get the data, you actually start developing your model, start coding, import from scikit-learn linear regression or something like that. Then you need to train your model, and it depends if it's if you don't have a lot of data, you can train it locally. But if, let's say, you have terabytes of data, 5 years of data, then you need some infrastructure for that. You need to start some EC2 instances on Amazon. Then you tune your model, you do the hyperparameter optimization, you use something like HyperOpt or Bayesian optimization to select the hyperparameters for your model. Then you actually deploy your model. It doesn't matter if it's just scheduling it on some server in cron tab or any other method. Maybe you need to do to make some API that will be called by your backend. Then there is a phase of predictions that are made. Then you evaluate the performance of this model in production, and then you need to manage this model as well, because you need to retrain it from time to time. You need to make sure that there is no drift, that it still performs as well as it was performing before. Then you need probably deploy a new version with several new features, but still maintain the old model for compatibility. So actually, it's quite a few steps that you need to do. And sometimes, if you're a big company and you have a team or several teams of data scientists, maybe 40, 50 data scientists, then it appears that people start to develop their own bicycles every time they need to deploy something into production. So in Careem, like about almost 2 years ago, as I said, company was started in 2012. So in like about 2 years ago, in 2017, we realized that we have several challenges. So first one, maybe it's specific to our business. Maybe some other businesses have similar things. But we need to deploy a lot of machine learning models that are specific to each city. And as I said, we have about 125 cities right now. So you can imagine if you need to deploy 125 models for every project, then it's a pain. Then what we need to do as well, we need to A/B test models. So we need to compare one model with the other model. We need to see like how the same kind of project will behave with the machine learning model or without the machine learning model. And then we need to do the real-time monitoring of those models, because if something breaks, so one of the examples that we predict the ETA, which is the estimated time of arrival for the customer. So if this service is down, then obviously we can have some fallback and we use all this fancy stuff like Hystrix on the back end, but then we show some default values, which are not that great. And it can lead to cancellations or lost bookings, which is lost money, basically. So we need to make sure that it's running, it's performing, and it's not that easy to do that with the existing tools. So what we decided to do was we decided to build something in-house. And I think that some people will ask, like, why don't you use something like SageMaker? But as I said, we started 2 years ago, so SageMaker wasn't there. SageMaker was introduced in November, and we started in July. So yeah, we're kind of pioneers in that field, I believe. So we developed our own machine learning platform, which was designed to actually, as we call it, evangelize or democratize the machine learning within the company. So we don't want data scientists to spend their time on, developing APIs using Flask and Python, even though some of them can do this, but not everyone is skilled to do this task. Someone is better, someone is not. Then we want to actually reduce the amount of time that data scientists spend on the engineering tasks, because it's not that exciting for a lot of people to actually do a lot of production coding. So we want data scientists to spend time on the R&D tasks rather than engineering. And then we want to make sure that the models that were developed within the R&D phase are performing in the production, perform the same in the production. So we don't want to data scientists to report that their model on their laptop has the recall of 99%, and then in production it's like 50% or something like that, or similar things, or in production it doesn't work at all. So what do we have now? We have about 25 live projects that are deployed and running on our platform. We still have some projects, some legacy projects that are not running on this platform, but it's legacy. So we have more than 200 models in production, and we provide for about 20 million predictions per day, which is probably not a lot, but for our scale, it's pretty good. So first step, as I said, there is a data preparation, and I want to share how did we solve this problem within our platform. So we have our data stored in S3 in our data lake, mainly in Parquet format. And we have a lot of tools that run on top of this. We have Presto clusters, Spark clusters, EMR clusters, Hive, and all of that. But for data scientists, sometimes I mean, they're not super familiar with those tools, so we provide them several interfaces. For those that are familiar with SQL, we provide them Spark SQL interface that they can. So basically, they write a Spark SQL query. They upload this file through UI or CLI, and it's going to be executed on a cluster and stored in Parquet format somewhere on S3. And it can be scheduled through Apache Airflow if they want to run this job like every day or every hour. And as well, we provide for some more sophisticated users, we provide PySpark and Scala Spark interfaces if they want to do some more sophisticated transformations. For example, some geospatial transformations on top of this data sets. Yeah, as I said, we have UI and CLI layers that enable data scientists to run this data set preparation generation. So some examples in the UI, it's pretty simple. You can just upload your SQL file, approve it, and run it. Or we have old school CLI interface as well that allows them to create some SQL file locally, then run it, parameterize it as well. So here you can see, you can say like within your data set, you can define some variables like days here. So you take only 90 days of last 90 days of data. And then dimensions is something specific to our business. So for us, every city or country or customer card type is the dimension. So you can generate this data set at scale for like all dimensions or some specific dimensions. Depends on your choice. So you can specify it here as well. Then it comes to the model design and training. So once you have your data, you want to, let's say, deploy some logistic regression or something like that for fraud detection. So for that, we provide very flexible environment to our data scientists. It's all Docker-based. So we have some generic classes that we've built, and we ask data scientists to create 2 or 3 files. So one called model.py, and there can be several models like model 1, model 2, or other names, which contain the model class and definitions. Then there is a feature engineering step that is defined in separate file, and requirements file as well, like depending on which packages do you want to use. So we package it all in Docker container. We have this data set Parquet file that you generated before available in a specific folder in this Docker container on S3, and then we allow them to pass some training parameters and the dimension as well, depending if it's city, country. And then we run it on AWS. We utilize AWS Batch for this. Then we have some generic steps which generate the evaluation reports for every model. And then we serialize the feature engineering and the model itself and store it in the pickle file on S3 as well. So I have some code examples. I don't know if you can see here. Maybe we can increase the brightness of the screen, because I think it's pretty dark. But for those who can see, we have several interfaces that we've built, so data scientists don't need to do any inventions. We have a class called training input that reads the file. It can split it into a train and test set, or it can split it into folds for cross-validation. And then we have model parameters defined. So in this case, we're taking the CatBoost classifier, and CatBoost classifier is the class from the CatBoost library itself. We define some parameters for that CatBoost, like the depth of the tree, the number of iterations, the learning rate, and then we pass it to the CatBoost trainer, which is our custom class, and then it's executed within the model that has some parameters like version and the training input and the instance of the model itself, and then there are some default reporting functionalities that report various metrics, let's say ROC in this case. And then pretty much if your model is not super sophisticated, this is the only thing you need to have in order to be able to run it on our infrastructure and then deploy it as an API later on. So in the UI, it looks like this. Once you run this code, you will have the information about the training job that was run. It has all the information that was defined before, like the dimension, type of project, environment in which it runs, because we support like QA environment and production environment. We encourage data scientists to actually test the code in the QA before deploying into production. Then you can you see the information about the so you see the information about the training date, because if it's scheduled, it's going to be training, for example, every day. And then you can go and see this pipeline generated on Airflow, because we use Airflow as the default scheduler. So, and then, as I said, there was a step for the evaluation metrics. So depending on the project, if it's classification or regression, we already have built-in reports that come with with those classes that we define. So for the classification, we have all sorts of classification reports, like confusion matrices and so on and so forth. We recently integrated SHAP as well into our reports. So data scientists don't need to actually, build these reports every time from scratch when they start a new project. It's going to be available for them by default, even as a black box. So those data scientists that don't do this, they will have it anyway. And for those that want to have some more sophisticated reports, we have some generic interfaces as well that allow them to define any type of report and store it in the UI. So then, as I said, we have the ability to do the scheduling of those models, so they run continuously. We have the UI interface for that as well, so you can select your project, which was already created, the dimension type, whatever is it, city or country or something else. Define how much resources do you need, like in this case, 16 cores, 32 GB of RAM. We say it's training job because we have support for batch predictions as well that can be scheduled. So for example, every week you want to get the predictions about the users that are about to churn, so you can schedule that as well, and it's gonna do the predictions, store them on S3, and then you can consume it later on. We have some integration with Slack that does the reporting and things like that. And then you can have some parameters for your data set generation, as I showed before, but in the UI, you define when you want to start, on what period, what intervals you want to run this, and some parameters for the jobs. And as I said, we use Airflow for that. It's just another UI that we've built and integrated with our tools on top of Airflow. So then, as I said, in a lot of cases, you need to have, you don't just want some model that is running and predicting a batch results in batch. You want to have a real-time API, and we've built some infrastructure regarding that. So once the model is trained, we have this pickle file that is stored on S3. So we have another Docker container that takes this pickle file, installs all the requirements defined in the requirements txt file. Then we have an A/B testing framework that we've built that is working on the front of this container and can A/B test various models against each other. Then we deploy it using the classical tool, which is Amazon Beanstalk. We support HTTP requests, either JSON or message pack. And then we have some additional features for data scientists that are available in that Docker container. So access to real-time aggregated features, because sometimes not all features can come through the HTTP request. For example, if you want to have some features like average number of trips for every user in the past months, probably the backend doesn't know this information, or it needs to extract it from somewhere. So we have an access to DynamoDB or Cassandra that stores all this real-time aggregated features that are accessible like in matter of microseconds, and some external APIs that can be called from that environment, like OSRM for route details. And as well, we store every prediction that we make, so we can do some drift detection or some analysis afterwards, and we make sure that it actually performs well, as I said. But this is all done in the background, so data scientists don't need to bother about that. So while deploying these models, we as well are conscious that we're working in the large-scale critical environments, so we cannot just deploy into the production and then see what happens. So we support canary deployment. For those who are not familiar, what is that? So let's say we have our old environment and we have our new environment, and then there's a load balancer. So we start rolling out the new model gradually, like 5%, 10%, 15%, and we check if there are no critical errors that are happening, that this model can handle this kind of load. If everything is fine, then gradually the new environment comes into the production. If something breaks, then we start downscaling. So this bad deployment doesn't go live, and we don't affect the critical services, which is very important, because like I don't think that data scientists will do all this kind of engineering part on their own, because some of them, they don't have this sort of background and knowledge how to do all that kind of things. So as I said, for the API deployment, we have the UI as well, which shows the status of the last deployment. We have versioning for every deployment. We specify like the dimension, as I said here in the UI, and different models. So in this case, we have 2 models for our fraud detection, which is one is the scikit-learn log regression, second one is the CatBoost model, and we want to benchmark them in this specific city. And then there are some parameters regarding the deployment, like how to auto-scale this, and in which environment to run this, and all of that. So that's all about the training and the API side. As well, for a lot of projects, it's important that all the metadata is stored in some place, documented in some place. And we faced a lot of issues before where people had like millions of production tables, no documentation. So what we did, we actually utilized Apache Atlas, which helps to track the lineage of all the transformations and ETLs that generate some data lake tables, like information about the particular trip. Because as you can see, like there are several steps here that result in one trip table, and that's not even the entire lineage. And sometimes if something breaks or something doesn't work, you don't know where is the problem. And the Apache Atlas helps us to track all the metadata and govern it in one place. And it supports all sort of data sources like Hive, Kafka, MySQL tables, and so on and so forth. So yeah. And then, so we went beyond that, and as many of you are data scientists, so obviously you perform the hyperparameter optimization in many of your projects. And sometimes you can notice that it's very like routine task. You do that over and over again, and you just sometimes copy paste the same code from one project to another. So what we built some sort of framework for most popular libraries that are used in our company and probably in other companies as well, like scikit-learn, XGBoost, CatBoost, LightGBM. And we built some generic hyperparameter optimization interface using hyperopt, skopt, Bayesian optimization that allows you to define the hyperparameter search space in the unified manner, and then use any of those hyperparameter optimization libraries with any of those packages. We do the automated cross-validation as well. We repeat it for like n number of iterations, and then we persist the final model. And for how it looks for the data scientists as well, I'm not sure if you can see, but compared to the old one, we have another class called HPO CatBoost Trainer, in this case, that takes no parameters. You don't define depths of the tree or anything else. You just specify the data set, which has some specific... so in the data set, there should be some specific format regarding the target variable. And that's it. That's all that needed. We do the automated inference of the categorical variables and the pre-processing of those categorical variables. And then you can just run it. So if compared to the old example, you don't need at all this part with defining like iterations, learning rate, even loss function. You can specify it if you want, but for majority of our built-in classes, we don't ask you to do that. And then the search space, so we have a team that works on defining like search space for every task, whether it's regression or classification, and for every library like CatBoost, LightGBM, and so on and so forth. So next step, we recently started working on some AutoML capabilities, because we have data scientists, but we have a lot of product managers in the company. We have a lot of people who are not sophisticated in data science, but they want to develop some baseline models. They want to play around with some data. And then as well, sometimes you just want quickly to have some baseline model to see if it even makes sense to go further and explore this task. So we've built our in-house AutoML tool, which is quite simple, but it takes as an input the generated data set. We have a set of predefined algorithms available out of the box. We run them in parallel. We perform the hyperparameter optimization as well for each of them. And then we measure various metrics depending on the classification, regression, ranking algorithm, like R-squared or ROC. Then we measure the training time and inference time that it takes, so we can compare different models, and then we persist those results and present the report to the user that ran this thing. And we have, for now, we just have the old school CLI interface for this. We're working on the UI as well to simplify all of that, so you can literally like drag and drop the data set and have the report out there. So, and then I want to take a few minutes just to showcase several AI use cases or machine learning use cases that we have and which are using the platform that I just described. So one of the projects is the suggested drop-off locations. So for example, to simplify the user experience, to reduce the amount of time that it takes to make the booking, to reduce the cancellations, we came up with the feature that is called suggested drop-off, where depending on various, like more than 200 features related to the particular user, location, time, we predict where you might go from the locations that you've been before or other people have been before. And it's a typical like supervised learning algorithm and a bit of ranking as well. And it's successfully running for more than a year in production. And we use it as well for some other purposes. The other one is the meeting points. So for example, in a lot of cases, drivers or captains cannot find the customer because the GPS signal was weak and it showed the other side of the building, for example, and so the customer is on one side of the building, the driver is on the other side of the building. It's very critical in Dubai, where if you're like on one side of the building, you might need to spend another 15 minutes to drive to the other side of the building. So as well, we developed this unsupervised learning approach to reduce the cancellation rate, to reduce the number of contacts to customer support, and to reduce the actual time of arrival, which are the direct KPIs that are impacted by this problem. And then we have some others like retention and customer throughput. It's a completely unsupervised approach that for now uses like a bunch of clustering algorithms on the back end to come up with the most popular pickup points that are suggested to the user. And if it's their first time in this location, they will be automatically snapped to that pickup point and will be guided to go there. And then as well, we run our food delivery business. So for food delivery, we have a classical recommendation engine approach where we want to, so we have thousands of restaurants available on the platform, and it can be hectic for every user to go through those 1,000 restaurants and select something that he likes. So we provide a personalized experience using various recommendation approaches, from classical collaborative filtering to some more sophisticated things that we as well A/B test in production all the time. So we don't provide burgers recommendations to vegetarians and so on and so forth. So that's about it. So moving forward, we have some roadmap for our product as well. We are working on enhancing our auto rollout features that allow us to, in one click, to deploy one model to 125 cities within a matter of hours. Then we want to enhance our AutoML capabilities by introducing some automated feature engineering things using libraries like feature tools, because right now we assume that feature engineering is done already, but we want to go one step beyond that. Then we want to supercharge our drift detection approaches that will allow to spot if the model starts performing badly and then take some actions on top of that. We want to improve the existing serving layer latency. So for a lot of we have a lot of tree-based models like CatBoost, XGBoost, and things like that. We want to reduce the inference time for those, go less than 30 milliseconds, for example. For that, we want to explore some libraries that allow to compile your decision tree into a binary format, like TreeLite, for example. Working on improving the UI and UX, and then adding things like permutation importance that is tracked by default and is available for data scientists out of the box without a need to code it from scratch. So I believe that's it. If you have any questions, go on.
And yeah. And now question, yeah, yes, please, the first one.
You mentioned improvement of drift detection in the future. How you handle model decay in real time now?
So for now, it's very simple. When data scientists develop or start developing their project, we just ask them for a SQL query that selects the actual predictions, the actual data. For example, if it's ETA, we have the predicted ETA and we have the actual ETA that was calculated after the trip is done. So we just join, because we have the prediction logging and we have this query. So we just join those two columns on the back end and calculate the metrics like R-squared or anything else, like mean average error. And then we run it as the daily sort of scheduled job. But we want to go beyond that and have maybe like near real-time calculations of those things.
Okay, the next one. Just rate you can't. No one. Oh, yeah.
Yeah, so thank you for such a good presentation. I have, well, two questions. So one regarding your training optimization. As I saw, you use CPU training only?
Sorry, you use what?
CPU training.
Yes, we use CPU as a default one, but we have support of GPU training as well, because it's just another type of Docker container.
Oh, okay, okay.
So there is NVIDIA Docker container.
I just saw only CPU only on your screenshot. Okay. And the next question is, who is actually the AutoML users? So I would suppose that maybe some data scientists would use it just to verify some hypothesis, and maybe some product managers would like to test some features, maybe some ideas. But I will hear the answer, your answer.
Yeah. So as I said, it's like product managers or people from the business who have some. Let's say they can write the SQL query to select some data, and they know that they want to predict some variable, a target variable. So for them, it's super quick to just go and run something. And if they prepare the data set correctly, then supposedly like the results will make sense. And as well, as you said, for data scientists as well, before they start the project, or while they're doing their R&D phase, there's no harm in just running this AutoML tool. But it's not. We've just started, for example, and we just like figuring out who will be our like main users, because we didn't spend much time developing and sophisticating this AutoML capabilities. We've built how it started. We've built the hyperparameter optimization classes, and then we realized that we can just when we discussed it, we said we're just gonna do like parallel for loop over some of the default libraries and do the default preprocessing of categorical variables and see what happens. And it works. I mean, not super great, obviously. The results are average because, I mean, we're not tuning that super hard, but.
Okay, thanks for the presentation. You mentioned 3 use cases. Actually, others. Is there something else, or can you tell us something more about use cases?
Yeah, we have a lot. I just put it 3 because as well, I'm not the only person. We have about 30 data scientists working on this stuff. But we have a lot of stuff in fraud detection, for example, like predicting like fraud on users, fraud on transactions from both sides, like customers and captains as well. Because like before I joined the ride-hailing business, I thought that it's only end users that request a taxi, they will make some frauds. But it appeared that there are like drivers that are trying to hack the system as well. So we have a ton of use cases in fraud detection as well, which as well, not a lot of them are running on top of our machine learning platform, because some of them are like legacy systems from before. A lot of things related to ETA prediction, time of arrival, how much time it takes for a driver to get a new booking, and as well a lot of things regarding, there's one guy here as well. A lot of things regarding loyalty and what kind of bonuses do we send to our customers, as well as drivers, because we provide a lot of subsidies for drivers as well. So yeah, there is a lot of things. We can talk offline about this.
Hi. I see you use Docker containers in the production. Do you have any plans move to Kubernetes and use solutions like Kubeflow or Seldon?
Yeah, so we currently we're exploring Kubernetes, but so it's a lot of work to actually move to Kubernetes, especially taking into account the fact that the team, it's not just me working on this. We have a team of 7 people only working on this, including the UI, UX. So it's quite challenging, but we're exploring how we can utilize, I don't know, the Kubernetes infrastructure provided by Amazon. And obviously, it's more attractive because it allows you to scale your models better and differently. For example, if you have a lot of load for Dubai and then not a lot of requests for Karachi, you can scale them separately. Right now, we just use a lot of resources for both models, which is not very wise probably. But yeah, we're exploring Kubernetes.
So you mentioned that in the case of hyperparameter optimization, is the data scientist who's responsible for defining the search space, right?
Yeah, so we don't ask them. So we as a team, we already predefine the search space, so they don't need to worry about that. And we obviously work closely with a lot of data scientists and machine learning engineers within the company to come up with this unified set of hyperparameters that makes sense for every library and every algorithm. And then we run it against some default benchmark data sets that we have, just to make sure that it's not some nonsense, right? So it actually performs well.
Question is normally for hyperparameter optimization and also for AutoML, the idea that the larger the search space, the larger the risk of overfitting. So how do you deal with that?
There is so we use some common knowledge that was gathered by all of our data scientists to actually make sure that we don't overfit. And then as well, we have several steps, we have cross-validation that we run to make sure that we're not overfitting. And as well, we have some holdout set that we use to benchmark our data set afterwards to make sure that it's actually performing well. So obviously, yeah. But then we cannot afford exploring infinite search space because we have limited resources, and we don't want every trial of hyperparameter optimization run costs us $1,000, for example, because then it doesn't make sense.
Yeah, thank you very much for your presentation. My question is regarding you show Airflow reports, right? Could you please describe how this look like in daily? So your data science training, and they generate these reports for themselves or for the management? And did you compare Airflow with MLflow or in other tools?
Yeah, so MLflow is, to be honest, is more similar to the tool that we've built. But again, it was released maybe a year ago or by Databricks. So it's not Airflow we use just to schedule our jobs basically, and as the more sophisticated solution for cron tab scripts that run daily, hourly, or something like that. And those reports that you've seen in the UI, it's more for data scientists and product managers to see visually what's the accuracy of this particular run or this particular model. So obviously for C-level management, you need to do a bit of extra work to summarize that, because not a lot of C-level managers understand what is ROC and things like that. But to your point about comparing to Airflow, yes, we comparing our capabilities with Airflow, but obviously we have a lot of business-specific features that we've built like regarding dimensions, for example, as I said.
And related question: are your data science using Jupyter notebooks, or are they using Python scripts, and you run this from this scheduler?
So what do we have? We have, I didn't mention it here, but we have our own Jupyter Notebooks infrastructure called Lightsaber that has all these libraries built in-house available out there. So they do their R&D phase in the Jupyter Notebook, and then we have some scripts that help them convert that to the actual training job, so they don't need to then either copy-paste this to the files or do some extra changes. They can work in the Jupyter Notebook, then run the script. It will do all the conversions, and then it's ready for the deployment.
Yeah, thank you very much.
Welcome.
Thank you very much. Thanks to our speaker. Yeah.
Thank you.